All right, in this problem, we're given tabulated data and we're asked to calculate delta H of reaction for this reaction that's given here. The first thing I'm going to do is write this reaction out. CO2 solid plus 3H2 gas, C3OH liquid plus H2O liquid. All right, sometimes I might be lazy and not put the state symbols that are here, but if you have a table that has, for example, the solid, liquid, and gas in an example, then they would have different delta H's of formation. So we need to make sure that we have the correct forms when we go up there. All right, now I'm going to just pull the data from the table. So this one is, for CO2, it's minus 393.5 kilojoules. For H2, so the delta H of formation for an element in its standard state is 0. If we want to be fancy, we can say that's 3 times 0 since there's 3 moles of those. They're just transferring my data from the table. Now I'm going to group it a little bit. So I'm going to take, okay, the math's not going to be super exciting on this left side, 393.5 since we're adding 0. And then here on the right side, let's add those together, minus 230. Minus 480.2. This is delta H naught for the reactants. So the sum of the energies of the reactants. Not super exciting since one of them in this way of doing it doesn't have any energy. And then this is the sum of the delta H naught of the products. So then for a reaction that we're interested in, delta H naught of reaction is the sum of the product energies minus the sum of the reactant energies. Okay, and so minus 480.2 minus a minus 393.5. Okay, and you should know this minus and minus is going to make this last term be positive. So minus 480.2 minus a minus 393.5 will give us overall here, once we've done this math, minus 86.7 kilojoules per mole.